Okay, so we'll just get right into it. Today we live during a strange time. Many have forgotten the power of imagination and are instead bogged down with the reality of practicality, the reality of the budget, and the reality of what is deemed useful and what is deemed useless. Many have come to the conclusion that the study and exploration of space is a useless endeavor, that we cannot afford to waste our time on something that is more akin to a child's fantasy, our immature dreams from our ancient past. This is not only false, but disregards the minds of scientists throughout the centuries who always placed the power of imagination at the helm of their navigation. Imagination allows us a glimpse of the unknown before we can confirm it to be known. It is with our ability to first imagine new possibilities that major discoveries can be born. This class will discuss ancient as well as modern Chinese astronomy, which, like ancient Egyptian and Greek astronomy, would not have made their revolutionary discoveries in science if they had not first dared to imagine there existed a purpose and therefore a knowable explanation for how the universe works. This will serve as a reminder to those of us who have forgotten or are in the process of forgetting that the study of astronomy has always been at the core of humankind's exploration for meaning and purpose. And if we accept such a challenge, the opening up of the most impressive kind of potential and responsibility for the future of humankind lies before us. Let us start our voyage in 1054 AD. Chinese astronomers at this time observed the sudden appearance of a new star in the sky, which was incredibly bright, much more so than any other star in the sky. This was not the first time that the Chinese had observed such a phenomena. In 185 AD, the Chinese were the first in history to ever reliably record the observation of a suddenly appearing star in the sky. This was a very rare phenomena and was nicknamed Kexing, which means guest star, since it would only remain visible in the sky for a short amount of time, around several months. The picture shown here is obviously not a real picture, but a digital recreation of what it probably looked like, although it could have been even brighter than this. There have only been 5 reliable recordings of such a phenomena in history, in 185 AD, 1006, 1054, 1572, and 1604. Though it was widely reported in China, other than Japan's note of it, only one other record exists from outside East Asia that is definitely known, an Arabic work which cites its observation, and may have originated from Constantinople, but it is not certain. However, it was the Chinese who would most accurately map and describe the guest star. In fact, the 1054 AD observation by Chinese astronomers was the first description of the guest star that met a standard suitable for modern astronomy, such that astronomers today rely on much of the data recorded from this 1054 AD documentation in their studies. The oldest surviving manuscript of a star chart is the Dunhuang star chart discovered in the Mogao caves of Dunhuang in Gansu, Western China, along the Silk Road. The map is dated to 700 AD during the Tang Dynasty. The map shows over 1,300 stars visible to the naked eye, centuries before the telescope was invented. However, there is much evidence to support that less complete Chinese star charts and catalogs go as far back as 4000 BC. This is a star chart of the south polar projection of the celestial globe by Chinese astronomer Su Song, who lived from 1020 to 1101 AD. These are among the oldest existing star maps in printed form, all from Su Song. Here's another example from Su Song of a cylindrical projection.
This is what year?
This is from 1021 to 1101. This is one of the Suzhou astronomical maps, and it was inscribed in stone in 1191 AD. It is now located in the Confucius Temple of Suzhou. It was created by imperial astronomer Wong and etched on stone in the 13th century. The Suzhou inscription astronomical map records known stars and constellations and is gridded into 28 lunar mansions, a map of the heavens based on the movement of the moon, rather than the solar mapping that forms the basis of the Western zodiac. The star map shows the celestial equator, the north celestial pole, the Milky Way, planets and stars such as Antares and Vega. So what was it that the ancient Chinese astronomers actually observed, and what is its significance? Before this mystery of the guest star is named, let us first go over what we now know about how light travels through space and what it consists of, since this was, after all, what the ancient astronomers were entirely working with, since they had no other tool at the time but the direct observation of light in the sky. Light is emitted in the form of electromagnetic waves. The above picture shows the different electromagnetic waves that are known so far, which consists of periodic variations of electric and magnetic field intensity. As you can see from the diagram, the spectrum of light that is visible to the human eye is very small. And by the way, these are all considered forms of radiation. The reason why space often looks black to us is several-fold. For visible light to travel through space, it not only takes time and is not an instantaneous thing, but it also depends on how light is being bent in space, if the light is moving towards us or away from us, and whether an object is actually emitting visible light and not some other form of light like gamma rays or radio waves. With the naked eye, we are actually extremely limited in seeing most of the forms of light, which actually fill all of space. That is, space, or better called the universe, is filled with light. Our eyes just can't see most of it. With aid of modern telescopes that can view various spectrums of light, we are much better able to appreciate the majestic beauty of what truly fills what we first thought to be just dark space. In addition, not all visible light is qualitatively the same. For instance, sunlight appears as white light to the human eye, but is actually made up of all the colors of the rainbow. It is in fact why we see the phenomena of rainbows in the sky, the effect of sunlight being refracted by rain droplets. That is, trillions of rain droplets are all refracting the sunlight at the same angle, such that you get the effect of an arc of rainbow. Think about how odd this phenomena would sound to you if you didn't have the ability to see it yourself. If you couldn't see the visible light spectrum, the sky would look like an entirely different thing. The sky wouldn't even be blue. Not all visible light sources in space generate white light, but can generate light consisting mostly of red, blue, or other spectrums of visible light. Our eyes do not see all forms of light equally, and therefore, even amongst the small spectrum of light that is deemed visible to the human eye, we do not have the capability to view certain parts of the visible spectrum as well as others. Our eyes alone are thus extremely limited to their ability to observe the night sky, even on the clearest of nights. But that is not the whole of it. How we see our surroundings on Earth in clear daylight is actually something we are also very limited in. Here is a comparison between human vision and that of bees, birds, and fish, which all can see parts of the ultraviolet spectrum, which we cannot. Hopefully, with just these few but quite dramatic examples, we can form an idea of how much of reality our naked eye actually misses out on. In fact, even our very concept of physical reality as something that could exist through sense alone is challenged. That is, for just sight, there exists no form of vision that encapsulates all forms of light. Therefore, there is no complete reality through one form of vision. Here's just an example of Centaurus A galaxy seen through multiple spectrums. of light. You see, you can get a very different story. In addition, there is the concept of how light travels. Presently, it is thought that all wavelengths of light travel at the same speed, and that this speed differs depending on what medium it is traversing through. For instance, light travels faster through air than through water. 1 light year is measured as having traversed approximately 6 trillion miles. That is, in 1 Earth year, light travels 10 to the 12th kilometers. This is probably not entirely accurate since it assumes that light will not change its speed through the medium of space, but it gives us an idea. So now, keeping this all in mind, what did the ancient Chinese astronomers observe as a phenomena in 1054 AD? Well, it is now thought that it is probably the death of a star, though it is still not completely certain. Otherwise known as a supernova, what is thought to be a powerful and luminous stellar explosion, and at its peak of brightness, the optical luminosity is comparable to that of a galaxy. The particular supernova of 1054 AD is called the Crab Nebula, which I will talk about later on in this class. Keep in mind that the only 5 reliable recordings of such an event, of a supernova, occurred in 185 AD, 1006, 1054, and later in 1572 and 1604. Therefore, the last supernova event to have been observed was over 400 years ago. In addition, now that we have the use of telescopes, we're able to calculate the distance between the Crab Nebula and Earth, and therefore are able to calculate that when the ancient Chinese astronomers observed the bright light in 1054 AD, this bright light, which was the explosion of the star, occurred 6,500 years before their actual observation of it. We should take a step back at this moment and reflect upon the magnitude of what we are dealing with. What we observe in so-called space, which is all based on multiple wavelengths of light, are all reaching Earth from various points in time. With further advancement in modern telescopes, we are able to see further into the so-called dark abyss of space through the lens of multiple spectrums of light and observing phenomena that have occurred within multiple points in time. In 2001, Chinese archaeologists launched a project to seek the origins of their over 5,000-year-old civilization. Taosu in Shaanxi province, sorry for my pronunciations, is one of the most important sites in this project. The ancient city of Taosu dates back to 4,300 to 4000 BC and is thought to be the capital of the legendary Yao period, which was from 2300 to 2200 BC. Yao was a famous sage king who ruled before the Xia dynasty, the first dynasty in Chinese history. Many Confucian histories praised Yao as a model of morality and benevolence. According to some Chinese classic documents, King Yao assigned astronomic officers to observe celestial phenomena such as the sunrise, sunset, and the rising of the evening stars. This was done in order to make a solar and lunar calendar with 366 days for a year, also providing for the leap month. In 2003, in search for evidence of the undocumented era at Taosu, Chinese archaeologists found the ruins of a mysterious semicircular building. After excavations, indications that 13 stone pillars were originally erected at the site were found, forming 12 gaps between them. Chinese archaeoastronomers have reconstructed the site to test the accuracy of the positioning of the stone pillars that cast the shadows to mark the seasons, and was confirmed as a functional observatory to observe the sunrise in order to determine the start of the seasons. This recent find has proven to now be the oldest astronomical observatory in the world, constructed and used during the Middle Taosu period, the 21st century BC. This means that the Chinese have thus been observing and cataloging the heavens for over 4,000 years. More recently, FAST, otherwise known as the 500-meter Aperture Spherical Radio Telescope, or nicknamed Tianyan, which means sky eye or the eye of heaven, was completed in 2016 and is located in Guizhou province in China. It is the world's largest filled aperture radio telescope. This telescope made its first discovery of two new pulsars in August 2017 and are 16,000 and 41,000 light years away, respectively. With FAST, we can observe more distant celestial bodies with fainter brightnesses. It is thus a powerful tool for detecting pulsars at great distances. FAST is equipped with multi-beam receivers which can detect thousands of pulsars in the Milky Way. It is theorized that a pulsar is a highly magnetized, rotating neutron star that emits a beam of electromagnetic radiation. This radiation can be observed only when the beam of emission is pointing toward Earth, much like the way a lighthouse can be seen only when the light is pointed in the direction of the observer. Neutron stars are very dense and have short, regular rotational periods. This produces a very precise interval between pulses that range from milliseconds to seconds for an individual pulsar. Pulsars are one of the candidates for the source of ultra-energy cosmic rays, which Matt will go over further. This picture is thought to be of a pulsating dead star that appears to be burning with the energy of 10 million suns, making it the brightest pulsar ever to be detected. The pulsar was found in the galaxy Messier 82, a relatively close galactic neighbor that's 12 million light years from Earth. This is a picture of the Crab Nebula, the famous guest star, or Ke that was first observed in 1054 AD. It is thought to be a supernova remnant in the constellation of Taurus. At the center of the nebula lies the Crab Pulsar, a neutron star of 28 to 30 kilometers wide with a spin rate of 30.2 times per second, which emits pulses of radiation from gamma rays to radio waves. It is generally still the brightest persistent source in the sky. Recently, as in the past month, the Crab Nebula hit the Earth with the highest gamma rays ever detected. What does this tell us about the Crab Nebula? By our increased ability to detect more clearly the range of energies the Crab Nebula is producing, we will better be able to understand what is organizing the dense star at its center. Detecting more of these types of events will also help to explain the origins of these superpowered cosmic rays. The process of light generation and propagation through the universe is still surrounded by many mysteries. Stars, like human beings, have a life cycle. They are born, they grow older, and they die. It is thought that the trigger of a star's life is gravity. The gravitational force pulls together the original nebula, a cloud of hydrogen. Because of the increasing density, the temperature increases, and a nuclear fusion process starts. Once this chain reaction is stable, a star is born. The Book of Changes, the oldest of the ancient Chinese texts, says, "Heaven displays its signs of fortune, and the sage arrives at his interpretations." This means that the universe is governed by its own rules. If you obey those rules, you will win favor. If not, you may suffer from disasters. Wise people know the rules of the universe, and they act accordingly. The purpose of astronomy has always been to study the correlation between man and the universe, not just the universe on its own. The Chinese thought and still think of the universe as the relationship among the heavens, the earth, and humans. The three parts are unified as a harmonious whole and can communicate with each other. Here is a great quote by Ye Peijian, head of the Chinese Lunar Exploration Program. He said recently, "The universe is an ocean, the moon is the Dayu Islands, Mars is Huangyan Island. If we don't go there now, even though we are capable of doing so, then we will have failed our descendants. In a very real way, space is our new unexplored ocean, with the planets and moons as forms of land, and the space station as our international port, with individual spaceships as well, ships on the sea. However, there is an immense qualitative difference between ocean navigation and space navigation. Unlike the news blips that sell on fabricating drama, our ability to function in space has always been based on cooperation. And despite it being the common thing that your crew members in space all speak different native languages than you, there is an undeniable union shared which may have appeared on Earth as a giant gulf of difference. This is a joint mission of humankind, and it will only flourish as a joint mission. Let us dare to imagine the potential behind the unknown.